Hi, good evening. Welcome to Juniper. This is a new campus for me. The last two times we were at Juniper, we were in the other building. So thank you to Tanya and the Juniper people. Um, where's Randy? Is he here?
He's outside. He's outside. Oh, Randy? Yeah.
But he has been in at some point, right? He knows where he's from. Okay.
He's,
All right. Well, normally we go to the other place. Not normally. Juniper has been kind enough to host us twice. I'm Lisa. Does anyone here not know me?
I'm Lisa.
Hi. So I've been, for those that don't know me, running this beautiful user group for 5+ years. So I know a lot of you here. Almost didn't make it today. Sorry about that long day. But I did make it, and I'm super excited because we get to do this one again. Some of you might have been here in, I think it was what, Robert, December? That we, sorry, didn't mean to bother you while you were eating. But yes, I twisted Randy's arm and asked him to do, well, first to present I saw him do a keynote on services as a platform when we were in Austin, and it was an awesome keynote. And I said, can you do that for our lovely user group? And he was nice enough to say yes. And then I was like, you know what? Actually, I want to do something different. I want to do an Ask Me Anything session with Randy Bias, because let's just pick his brain. Let's just go there. And he was kind enough to just expose himself and to let us do that and go there. And we went there. So I want to make sure. So we tried. So we're going to recreate that a little. No pictures. No, bless. So we're going to do that again a little bit. Although now I've brought in another friend of mine, Henrik. Who we all go a long ways back. And so he's going to be doing part of the Ask Me Anything stuff. And they're going to go back and forth. And I guess Robert is part of the asking as well today. But we still want this to be interactive. For those of you that were at that Ask Me Anything session, I think you remember we kept Randy about 2 hours with questions. He was like, are you sure you're going to have enough questions? Like, should we get some questions ahead of time? I'm like, oh no, this user group, they're not shy. And they will have questions, and they'll bring it, and they'll be really good questions, and they were. You guys brought it. So hopefully you'll do it again. And we all learned a lot that night, and it was a lot of fun. So hopefully you have a lot of fun again tonight. I also want to let you know, so Kriti is still really not here. She promised. Kriti? Okay, well, or anyone from Oracle. Did anyone sneak in since the last time I asked that question 5 minutes ago? Okay, all right. So our next meetup on November 1st, I believe, is at Oracle. It's the rescheduled one. Sorry. Apparently none of you wanted to drive to San Francisco. So I didn't either. So I was also going to miss that meetup on a weekday. But so we've moved it to the Oracle campus. So November 1st, we're going to be at Redwood Shores. It's a beautiful campus. I know. I did hard time there. I was there. I want to tell you what years, but I was there for 6 years, a long time ago. And but they didn't have a boat in the middle of that lake. This was pre-America's Cup. That boat is still. It's not the one that they have two boats, right? They have the practice boat, and then they have the one they won the cup with, and they toggled back and forth. Anyway, it's apparently the really big one would fit in that lake, but the other boat, which is still really big, is in the middle of that lake, and it's actually really kind of cool to see. So I hope you all join us on November 1st up at Oracle, a little earlier. So diabolical. You're all going to be sitting in traffic. Sorry about that, but I think it starts at 6. So, or the networking part of it does. So I hope to see you all November 1st at Oracle. Also, as always, if you have a burning topic you want to talk about and you want a user group to pitch it to, we can come to you. So happy to move it around and host. I don't have anything planned for December right now. So except for KubeCon. It's just a little show that we're doing. So I'll be a little busy in December, but we can squeeze something in as long as it's not the week of KubeCon. So let me know if you have a topic that you want to discuss. Does anyone have any questions before we start? Logistics questions. Where's the bathroom? Randy or Robert?
It's on the left.
On the left. Okay. Men's and women's bathrooms are on the left. You just go out there to the left. Okay. Anything else? There's pizza. The guys were nice enough to get me a couple of gluten-free pizzas. So I'm not going to eat 3 pizzas. I promise you. So if anyone else is gluten-free, the little ones on the left are gluten-free. Thank you, by the way. You got the pizza?
Yes.
Thank you, Robert. Thank you, thank you. Wow, the guy from you make the guy from Tennessee come in and get the pizza? Okay.
They have this thing called the internet. It's actually pretty easy.
Who did the beer run? You did the beer run too? Wow. Wow.
Safeway was across the street from
I know, but I've run 101,000 meetups and I've done 101,000 beer runs myself, so I know how hard it is. Thank you. Can everyone give Robert Cathy a hand for doing the pizza and the beer run? This might be the first time ever in the history of the 5 years that I've been running this that someone did the beer run for me and didn't just like phone it out to catering. I love that. Thank you. That is the kind of effort that we bring to you. So thank you for that. Okay, so any other questions? Those weren't any questions. All right, I think we're all good. Okay, so then I think how this is going to go, you're going to moderate the Henrik Randy show in the beginning, and then Greg's going to come up.
Yes.
And then
Where's Greg?
he's back there.
Okay.
Do you want everything to be interactive the entire time, or just at the?
Yeah, I think that if people have questions, they should just shout them out. But we do have some dedicated time at the end for Q&A. So whichever strikes you is fine.
Okay, and so when we do Q&A, someone will run around like a crazy person with them. Are you recording, right? Yeah. So someone will run around with a microphone so that it can be live streaming or just live streaming and recording or just recording?
Just
Recording. Got it. Okay, good. Okay, so either way, we want the questions on the microphone because otherwise the recordings. Because believe it or not, this is a global user group, and I get lots of emails from people if the questions aren't also on the recording. So unless these guys are diligent and repeat every question, I'm going to have someone run around. It's probably going to be me because that's how it usually works out with the microphone, so we can get your question on the microphone for the recording. I know it's a small room, everybody's gonna be able to hear, but that's what it's for. And lots of people do listen to these things. We have a YouTube channel, so choose your questions wisely. Make them good. Make them questions and not lectures or speeches. Let's go with questions. Okay. And also, OpenStack Summit is in Berlin in November. So I hope all of you, is anyone planning on coming to the OpenStack Summit? Only one person. Yeah, it's like, last time. Really? Whoa.
I wondered, but no budget.
Wow. Rocky has a whole release named after her, and you'd think you'd just be an honorary, like we should fly you there in like a, the Concorde or something. But okay, who's coming to KubeCon? Seattle. Okay. Still not as many as I thought. Okay, I ask this every time because over the 5 years, those hands have been getting less and less and less, and that just reminds me that we need to bring the content to you. So, which we do. So we will make sure that we'll take a couple of presentations that are going to be at KubeCon, and we'll feature them here over the next couple of months. So we will bring the content to you. But that's just always good for me to know who's going where, because it's always surprising to me, because in the early days when I used to ask that question, literally 3/4 of the room raised their hands, and it's been less and less ever since. All right, we're top of the hour. This is when I promised you that the content would start. So what I just did wasn't content. I was just saying hi. So hi, everyone. Good to see you again. So I will hand it off to you at 7 o'clock. You ready?
Let's rock.
You ready, Randy? You ready, Robert?
Come
you
on,
ready,
guys.
Henrik?
Yes.
Okay.
And I brought some
Greg, come
technical
on up.
backup, by the way, so Gary
Oh, for the whole time? But
Yeah, yeah.
One thing I can do.
Yes.
I need to say-
Oh.
Sheet.
You brought technical backup?
I did.
Where's my technical backup?
That's your fault.
All right. Yeah, the thing about the questions and the mic is no joke, because otherwise, when people are watching it later, they hear, and it's just kind of pointless. So yeah, when you have your question, be sure to shout it out. Now, of course, I can't find my slides. All right. So what I'm going to do, how many people saw the abstract and actually looked at the abstract that was online? Yeah. All right, great. A few hands come. So the premise that we wanted to do tonight was, with the advent of a lot of conversation in the community, various open infrastructure communities about containers, and should containers run on bare metal? Should they run nested in VMs? What about projects like Kata containers, where you try to run a stripped down VM and just have the bare essentials so you can spin it up faster and make the attack profile smaller? What's real and what's not? And so Henrik and Randy and Greg agreed to sit down and just kind of debate this and throw some things out. The point of this format is not so much that the oracles, the 3 oracles we have here, come down from the mountain with stone tablets with a mix of my metaphors. But that we have some disagreement and we have some argument, because those arguments, those disagreements, that froth is where you really start to highlight some differences in approaches, because there's more than one way to solve the problem, right? So we put together those topics that you saw in the abstract as just a guide. And if you have your questions, just shout them out. What I want to do is let everybody introduce themselves. Henrik, we'll start with you.
Cool, appreciate it. Thank you, Robert. My name is Henrik Rosendahl. I run business development for NeuVector. NeuVector is, the short version is it's a Kubernetes security platform. It's 70% firewall and network-based security, and 30% looking into processes and files and doing vulnerability scanning and that sort of thing. But we're sort of here in the house of Juniper, and so there's some interesting overlaps with these technologies.
Great.
Yep.
My name is Gary Duan, so I'm the co-founder and CTO. I also run the engineering team in NeuVector.
I'm Randy Bias.
Oh, come on.
Well, I mean, the problem is like any kind of good introduction takes too long.
Well, let's not do that.
For those who don't know me, I was well known in the OpenStack space. I built one of the first startups that was an OpenStack startup. And then before that, I've got a long history of doing systems engineering, network and backbone engineering. AS2828 is my baby. Data center build-outs, InfoSec, solid for 7 years, but also part-time is the rest of my job for a lot of that time. I grew up on SunOS 3.1 and SCO Xenix when I was 15 in 1986. And I've been buried by the IT bug ever since, I guess.
Santa Cruz operation.
I live in Santa Cruz. My mom worked in Santa Cruz. Operations.
All right. So what we'll do is we'll kick things off. We'll start with the obvious topic area. Happy holidays, everyone. I'm not sure why we suddenly.
It's
a fireside chat.
It is a dumpster fire.
Yeah.
Pretty sure that's not the
Please don't see okay, so most container infrastructures do run in some sort of nested VM environment. Google, I guess, still does that predominantly. But let's start there. It's this common assumption that nesting is a best practice for security. Is it? Is that the best way to go about it? What do you go? Henrik, let's start with you.
Yeah, I mean, we're out there installing Kubernetes in, at this point probably over 100 enterprises here in North America, and the most sort of common way of of running Kubernetes is really on EC2 if you're running in Amazon. Very few larger enterprises have adopted the sort of the pre-baked frameworks. So we don't really see EKS. I mean, people are playing with it, but as a sort of a general means of deploying Kubernetes, we see classic sort of EC2, run your own VMs, and then you are free to pick up and move it to some place else if you so desire. So I would say that's like 80% of the implementations.
Gary, should it be 80%?
Well, I think so, and think most of our customers are using virtual machines. I think the benefits not only the security benefits, but also the operational. So you can clone, you can migrate, and if your virtual machines get compromised, you can start over. So that's, I think, the major benefit.
So when I first got exposed to containers, I was running something called FreeBSD jails, 2004-ish. That's about the time that Google contributed back C groups, which really started containers within Linux. And for those of you who are around at that time, you probably know that FreeBSD jails did not run inside of VMs. Containers are commonly referred to as operating system virtualization, sometimes application virtualization, which is different fundamentally than hardware virtualization. And as I think many people know, the concept of operating system virtualization has been around as long as mainframes, right? So it wasn't a new concept. And I think one of the services that Docker did for this world is it basically packaged up containers and made them easy to consume And one of the disservices it did to this world is it packaged up containers and made them easy to consume. And the downside is that, people said, oh, I've got a VM here, I need to make a container, I'll just take everything in this frickin' VM and stuff it inside this container. And the net result has been that something that I initially used in 2004 as a security mechanism is now actually, the source of a lot of security consternation. And what I mean by that is, when I was using it, we were building this scale-out cluster to do natural language processing search engine in this crazy startup that would catch me over beer sometime. It was totally insane. But one of the things we did is we decided that we needed to basically take all the services that we were using. They're all based on new Lisp. Don't ask me. I told you a crazy story. And we needed to put them stripped down as only the application code plus its library dependencies, anything else it needed inside the FreeBSD jail. There's literally nothing in there. These are teeny, there are like tens of megabytes in size. Right, the attack surface was tiny. And then we ran them as unprivileged users. Right? And they didn't have access to do anything except send packets out to the network. They couldn't send it to another container, another jail in the same box. They couldn't send it to the host box. Right? And we made sure that each one of those jails ran in its own file system that had only the permissions for that unprivileged user. So accessing that container over the network, exploiting it, you'd have to get through that incredibly small attack surface. And then once you were in there, you had no tool chain. You got no compiler, you got no scripting languages, you got nothing. So you'd have to bootstrap all of that. And then once you had that, you'd have to figure out how to escalate your privileges into root. I mean, those are very, very, very tall hurdles to go through if you know anything about security. So what happened, in my estimation, is that in many ways Docker kind of ruined things because containers became a packaging exercise for application developers. It just became an easy way for me to package up my application and shove it around, but there's not a lot of thought to it. I've seen containers that are gigabytes and gigabytes in size. It's just crazy, right? But I believe that if containers had been used in a proper way, that they actually would be much more secure than VMs. And in fact, my crazy idea at Cloud Scaling Days with Paul Guth over there was at one point I wanted to use containers to host KVM instances inside of the container to increase the security of the KVM instance. So I guess I'm just trying to say in a long-winded way that I think that it's just been done wrong.
So I'm going to start passing this microphone down. What about the project that Intel, Clear Containers, worked with HyperSH and created the Kata Containers project? Is that a better way to go at it? Let's start in the middle this time.
Well, yeah, I think, well, in a way, it does increase the benefit to the security because you can essentially run the virtual machines, right? The Kata or the Clear Container initiative. Essentially, it's a virtual machine, but I would say people, when they using virtual machine and the container, not only they got benefit of scalability, manageability, also they talk about how to oversubscribe your using your CPU and memory. And well, I believe this technology has the benefit of the security, but it introduced a lot of overhead. In terms of managing, for example, if you say the diagram of how they can integrate with Kubernetes, there's a very complicated proxy and have to talk to the agent running inside this virtual machine. So that's introduced a lot of overhead. And I have seen some statistics reports like at least like 30% of CPU or memory overhead introduced by this container VM.
So wait, the 30% of the
That's from the VM.
From the VM.
It's just the VM.
Just the VM.
And that's like if you're using KVM as just a
Doesn't
full-size hypervisor, or
Well, on top of the hypervisor VM, the container VM introduced another 30%.
Got it. Wow.
Part two of my previous rant because I wanted to cut it off. I guess it's just the security person in me. Like when I think about how things are secure, I don't think about the hand waving that some company like VMware does to tell me that something's secure. What I think about is my own eyes and what I can see. And hypervisors have some inherent problems, right? The most important problem is that the attack surface is huge. And people don't get that at first because what they think is, well, the lines of code for hypervisor is relatively small. This is very true. However, if we look at the PV drivers, the paravirtualization drivers, which are required to get good performance, paravirtualization drivers are millions of lines of code in the aggregate. They come from dozens and dozens of different vendors, Ubuntu, Red Hat, Microsoft, and so on. And they have to run with relatively privileged capabilities on the back end at the host level where the hypervisor actually is. So if you're inside of a VM, it is possible, and the largest attack surface is to go through the PV drivers, right? And most of that code is, not super well vetted, unlike the hypervisor code. So my crazy notion is that containers, which have little or no code, have a much smaller attack surface than VMs, which have significant amounts of code in the form of the PV drivers that run inside them to get reasonable performance. And what people like to point to as a way that hardware virtualization actually provides some kind of security guarantees is by this isolation notion, right? Because I've got a kernel running inside the VM, because I kind of have my own virtualized hardware, I've got isolation between the different instances. But if you agree with me and you think that the PV drivers themselves are a large attack surface, and millions of lines of code that are not well vetted, written by tons and tons of different vendors, then you got to ask yourself, really, how secure are they? And there have been a lot of privilege escalation through the hypervisor, through the PV driver exploits in the past.
I don't think I can add anything to this.
All right, well then
Robert, go ahead.
Let's talk about
Just,
your
just jump on it, man.
Okay.
Don't wait for that.
I'm sorry.
One there and one here. So, when you point about the parameterization drivers being buggy, I'd also
All code is buggy. My point is that the number of lines of code inherently makes the attack surface much larger. Period.
I was going to say namespaces are inherently buggy themselves.
Sure.
But it's so much easier to go process to process, i.e. from container to container, than it is to go from VM to VM. I can attack a container, I can get into the host kernel a lot easier than I can from a VM.
I think that's an open question. I think if the container was configured properly, it's not as easy as you say it is.
Also, I think that when you consider security, not only the system security, also the application itself. If you pack, I guess that's your point earlier, is you pack too many applications, like typically a VM does, then you get more.
You get a 0-day access to my Java application. Well, let's make it even harder for you. My Go-based application. You've got a shell. You're user Bob, right? You've got no access to any tool chain. You've got no compiler. You've got no Perl. You've got no Ruby. You've got no Python. You've got no anything. The only libraries that are on there are libc and a couple other things. Okay, break out.
If you set it up correctly.
This is the nut of what I'm trying to convey. And the thing about what I'm trying to say is that if you think about it, all this stuff is very fixable, but people are lazy about how they put stuff in the containers. They're extremely lazy about it.
I just want to clarify about PV attack surface. Are you arguing that PV attack surface is larger than the host kernel, or just that it's larger than the way people think about it?
It's much larger than the way people think about it. They are used to thinking about the hypervisors being relatively secure, and it is, because it's hundreds of thousands of lines of code instead of millions. And when we suddenly expand that dramatically, the attack surface grows, right?
So it's a two-part question. So Henrik mentioned that you see about 70–80% of people running containers inside a VM, but then you kind of almost like clarified it by saying you see people running on EC2 instances. It's not like in Amazon; it's super easy to run on bare metal. So are you seeing it in public cloud, running the VMs because
that's what you do.
Right. So if you transport that onto on-premises, right, into private data centers, does that statistics change in any way?
I would say a very few customers that are implementing very large, homogeneous infrastructures will run bare metal.
eBay's running bare metal for all their Kubernetes deployments at the edge, for whatever it's
But if you have like an application sprawl, they end up in VMs, and then they're running Kubernetes in VMs.
Private,
Yeah.
data centers or whatever.
Yeah, private cloud or whatever you want to call it. Yeah, on-prem. Yeah,
VM.
absolutely.
And then the second question is maybe for you, Randy. if you would have to start from scratch, would you go with bare metal or VMs?
Metal.
Metal all the time.
VMs have a lot of overhead that I don't think are necessary. And what I used to do when I was building my FreeBSD jails is I would run the app and I would use like strace to basically figure out all the code paths. All that stuff can be automated. I don't understand why we don't have tools that allow you to execute an application in a restricted environment like a VM, and then you watch what the application does, you model it, and then basically you build a container that's form fit to that. Instead, what we do is we lift and shift everything out of a VM into a container and pretend that like somehow that's a container. I just don't think that's a container. It's a lightweight VM. We're running it inside of a big heavyweight VM. We don't have a lot of advantages. And I think you mentioned that Google's running containers in hypervisors, and I'm almost certain that's not true. I don't know if there's anybody here who knows for sure, but my understanding was that Google didn't like to take any performance penalty, and they certainly didn't want to take a performance penalty for hypervisor. I think there are little or none in that.
My information could be, well, my information is a year old, so they may have.
It's meant to be Google Cloud or Google.
Not Google Cloud. Google.
Google.
Google internal.
Yeah, it's all metal. So the people who did the primary, instigated the container thing way back in the day, have always.
But that also fits the profile well. You can sort of build tooling and security and management into an application stack if you control top to bottom. Right?
Let's talk about that. Let's talk about the tooling. If bare metal, and it seems there's a consensus here, bare metal is the preferred way to do it. Is the tooling mature?
No.
All right, let's talk about that.
Well, so my point here is we've spent 15 years getting deep into the world of VMware and the processes, and there are sort of established procedures from A to C. And if you have a sprawl of an application environment, which most enterprises do, then that's the preferred method. That's that's what they're comfortable with and know how to do. And so the tooling is.
I'm gonna jump in on this, Henrik. See, the thing is that containers are mostly antithetical to sprawl because you have to use the same kernel for the most part, which means you're not running Windows containers on a Linux host. So actually, most of the people who are successful with containers are running relatively homogeneous environments, and there's not really an application sprawl. Now you could say, I've already got an application sprawl, I've already created my virtualized silos with VMware, and so I'm just going to keep using that stuff, which people can, but then I don't think that you get all the benefits of containers that you possibly
But then all of a sudden now you have an environment where you got a VMware environment for and a Kubernetes environment, and they will live side by side.
Well,
and so
side
why
by
not?
side or one on top of the other.
Right, but what we see most predominantly is then customers opt, if it's an on-premise implementation, to run the whole thing on VMs and then just pay for the performance penalty because at least they have the established processes down.
Absolutely.
Yeah.
There's no doubt that the maturity of VMs versus the maturity of containers is day and night.
Right. It removes some variables, right, and they're willing to pay for it.
Yeah, I do think if they're experienced team who can manage their cluster, they tend to use bare metal. We do see some users, they have this very huge node with 1,500 to 1,000 of containers running on that bare metal. So that's certainly possible, but for other users, still more users are still using virtual machines.
What about deployments where an organization has a VM-based private cloud running OpenStack and they want to use Ironic within the same infrastructure to run their containers on bare metal? Is that a worthwhile approach?
Ironic? If you like pain.
Can you be more specific?
Ironic's a shitty bare metal provisioning system.
Is there a better one?
I think we shit-canned it, didn't we, Paul?
We did.
No. maybe go see the rack end guys. Rob would love to hear from you.
We use MAS for that.
Maz? No
If you're
comment.
going to do bare metal, we are going to go container native on bare metal with 10,000 containers running anytime.
The fundamental problem with bare metal provisioning, if you're going to do metal, it's better for you to, in some ways, be responsible for the operating system itself as a team. The problem with bare metal provisioning is that people are under the impression that x86 boxes and x86 boxes and x86 boxes and x86 boxes, and it's not. No. We used to get hundreds and hundreds of people who are successful at doing bare metal have very large hardware management teams like Google and Amazon and so on. And bare metal is actually very, very hard. It revs very frequently. The chips rev very frequently. The firmware revs very frequently. The differences between IPMI and the different vendors is, just nerve-wracking. And it's just the in-combinatorial support matrix that people see with any kind of software that you run on hardware, like VMware's kind of support hardware compatibility list. That just gets blown out of proportion if you try to build a bare metal provisioning system that can handle say the last 10 years of x86 boxes. It's really much too hard. So it's better if you can to pick a vendor, a bigger one like a Dell or God forbid HP, and to really standardize on a very small number of configurations and one particular operating system. And if you're really diligent about that, you can get it to where you can really kind of turn them out regularly, and in that case you can make it work really well.
No, I agree. We do have standardized on 2 Linux OS.
You're the Moss man.
I'm the Moss man in some way. So we don't really have a big diverse set of hardware and software running different versions. But what we do have is a very large build system. The build platform is so huge that every single user needs 2 terabytes just to run his build. So we can do incremental builds on a container within an hour with a bare metal. It takes 4 hours on a VM. So the best way we have handled the whole layer is we have abstracted what the user needs done.
So when you need to put on a new firmware, a new BIOS on the motherboard, and you have to boot into it's super relevant, super important because you have to standardize your metal.
Yeah.
So how do you guys do? You have a mechanism for booting into DOS because all the firmware update software is in DOS and reflashing the BIOS.
Yeah. So it doesn't all happen at once. It's all rolling updates. So one of the key things that I when designing the system was. What we decided was we cannot have concurrent downtimes on multiple nodes. So we need a distributed file system or something like we've been looking at companies like NetApp for a distributed solution. But recently I've been looking more at Portworx that has a layer on top.
Where's Lisa?
So, he just went outside.
Okay. So you're a little bit more in the weeds than I want to do. I want to understand how you're solving the bare metal challenges.
So bare metal challenges.
How do you in an automated fashion configure the BIOS for vendors that don't have any APIs to configure the BIOS?
So in our case, that's not a problem because we have vendors who do have.
Right. You picked very specific vendor that has some of these capabilities.
We didn't go on the rails and said let's go open compute and I'll build my own ASIC. That's all we did. We found the right mix of hardware that will be supported.
Yeah, that's how you can make it work. Yeah, that's
so
right.
The big challenge we do notice is in terms of security. So container, when you said a user can SSH into a container, and they may have, oh, you didn't say that.
No, I wouldn't let somebody SSH into a container.
Okay.
They're cattle, dude.
So
if it stops responding,
yeah, in our case, we do have to allow users to exec into containers, and then they can, to avoid security around that, we've restricted users not being able to SU or reboot or do anything that is malicious outside of their framework. So all they can do is run their process and get out. That's it.
Right.
So there are third-party utilities. I don't know if you guys are into Istio and looking at third-party tools like Gosu and others. So we are implementing those components as well.
Okay.
So I'm really interested in knowing how you would solve some of the problems in a bare metal world. I
go back and resurrect the Sun Opterons with the service processors. That's what I would do.
LXC containers came out of Sun, so I can't disagree with you on that. But one of the things that I definitely would like to understand is how you would implement TLS or other network security into that mix.
I guess I've been avoiding the questions about network security to a degree because, I mean, those don't really fundamentally change that much with containers. Yeah, they changed with Docker's crazy networking thing that got, yeah, anyway, we don't need to talk about that. But Kubernetes kind of unfudged that. You see how I sidestepped the actual F-bomb? You didn't even notice that, Robert.
No,
Unfudged. Unfudged, that's my new one. Unfudged. But you know, a lot of it's the same, right? I mean, TCP/IP is still TCP/IP. It hasn't changed when you're running it in the container, right? I'm not 100% sure what to say there. NeuVector's got solutions for that. Juniper's got solutions for that. I'm not really here to talk about products. I do think that one area that I think is still kind of underinvested in is the notion of distributed security mechanisms, right? I mean, you see VMware, they're like, oh, vArmor, just slap a virtual firewall and plug it into the VM, right? And I just, it's pretty old school, right? I mean, none of that stuff really scales very well. I'd like to see a lot more of kind of what EC2 security groups brought, kind of more of that distributed firewall. I'd like to see people trying to solve a lot more of the problems about how we get to deep packet inspection, layer 7, with those distributed firewalls. That's a hard problem to solve, right? If you can solve those kinds of problems, you can make a lot of money. And probably more importantly than anything else, I think that a lot of the paradigms of security that we've had for so long are starting to break down. I mean, I feel like a broken record because I have to say this every time I talk about security, but the security is designed, the whole security industry, the security professionals, everything is designed around the gates and moats, walls. You build this static security infrastructure and you're like, it's never going to change and people have to, hop through my defense in depth to like fix everything. Except we live in a world now where everything's changing constantly. We're rebuilding, we're releasing, we've got, these 10 containers go away, another 100 spin up there. And in that kind of world, I really think that the security needs to move closer to the application. So harping again on we're doing containers wrong, I'd say if you start by having a set of tooling that allows you to strip containers down so they've got a minimal attack surface, if you do things like take some of the clear container technology, some of the hypervisor technology, and you start to build it around the container so that you've got a more dynamic, lightweight kind of suit of armor that follows the application wherever it goes, like that's a better paradigm. And I just don't see people pursuing that because the way that a lot of the regulatory and compliance measures have been set up is like, I can say I did all the things on the checkbox, I checked all the boxes, and then when shit goes sideways, that's not my fault. I followed all the rules, right? And I just think that that's really sort of a problem. And then the second part of that, and I'm sorry, I'm bogarting the mic, is that I'm seeing certain people go to the next level with security. Like there's a company called WallArm that disclosure I'm an advisor for, and they've taken web application firewalls, which are basically useless, and they've added machine learning to the equation so that you are not just sticking some arbitrary set of rules in front of a web application and saying, block all this stuff because I think it's bad. Instead, you're learning what the normal traffic is to the web application, you profile it, and then you basically, block everything else. That kind of anomaly-based detection where you're leveraging machine learning and where you're bringing sort of that kind of technology closer to the application itself, that stuff's going to scale out. It's going to scale out really well. You're going to be able to leverage GPUs and other specialized kinds of chips to make it really fast. And I just really think a lot of that stuff's sort of underinvested in, underrepresented in, because what we're trying to take all the old security paradigms of firewalls and stuff, sorry, Henrik, and jam them into container land, and I'm just not sure that that works other than as a stopgap measure. Oh, I'm actually probably the mic.
So I fundamentally agree with you on the latter part of this, where security has to be much closer to the application, and that is possible, in a different way in a containerized environment. You did say something that I profoundly disagree with, which is it's still TCP/IP and it's still the same. The whole reason for NeuVector existing is that it's not the same. 30 years of network and security policies have been based on IP addresses and ports. And machines that you could point to and saying it's that guy. That's the .10.9, right?
Are you going to make
and,
a pitch on intent-based policies?
and now all of a sudden you have these ephemeral workloads that may exist for 5 minutes, may exist for 5 days, and by the time you get around to identifying a security breach, that thing is
still
long.
ports and IPs.
They are, but they are they're very ephemeral and they're very fluid. And
that was my point.
And none of the static sort of policies of the old world, pardon me, will conform to this environment.
Yeah, the network doesn't change, and even the attack vectors, they don't change, but the way the problem present themselves actually changed. Mostly distributed, very short-lived workloads.
Let's take one more question on this topic, and then we'll move on. There you go.
So I know you digress a little bit out of provisioning, but what I can't comprehend is where's the difference between provisioning bare metal, hypervisor from bare metal, and provisioning VM on top of it, and provisioning containers in it, versus just provisioning an operating system on top of a bare metal. Wouldn't I have to basically use more tooling to set up hypervisors first, as opposed to less?
Yeah.
So I don't understand the premise of that was given in the beginning of this subject where tooling is immature. Tooling is the same. You just hit APIs and execute calls.
No, when I'm talking about the tooling, I'm talking about the tooling for building, creating, and maintaining containers. And I'm talking about the real foundational container itself, not how Kubernetes manages a group of containers. Right? So right now, developers are left to themselves to make decisions about how they create a container. And the set of best practices is port best. And your average developer, very frequently is hacking on somebody else's code or application, or and they have no idea what the actual code paths are, right? If you want to take an application and you want to reduce the attack surface of that application, right? You want to make sure that if somebody gets a 0-day exploit and they can get in, they get in past the application, say they get shell access, right? You want to make sure they don't have access to anything past that. Well, if you bring all the rest of the operating system with it, you've got all of the shell languages, you've got Ruby, you've got Python, you've got just a potpourri of different tools that you can then use as the attacker to escalate your privileges. If in the container, there's only what the application needs to run, only the libraries that it executes, only the things that happen during its normal code execution, then if you breach into it somehow, if you can even get a shell, because it may not even have a shell in the container, but if you can, right, then it's very hard for you to get any further. But the tooling to allow you to do that easily as an unsophisticated developer who doesn't understand security, who doesn't understand about, I hate to say this, but probably a fair few of them don't even understand how shared libraries work. And if you don't have the tooling, it makes it easy to do that. What a developer defaults to is like, well, I'm going to reduce the risk that this is going to break, so I'm going to shove every frickin' thing that I might possibly need in there with it.
Right, but that sounds like it's a container packaging problem versus
it's a container packaging
bare metal versus hypervisor problem.
That's correct, and that's been my point from the beginning. I'm sorry if that wasn't clear, is that the container problem for me around security is that Docker made it easy to consume containers, and they made it so that by consuming containers in the way that they gave it to you, you would do it the wrong way by default, because it's so easy.
Yeah, that's one of the points I was saying, is we have made our own service layer, so
Yeah.
developers are never exposed to Kubernetes.
Yeah, and they probably like that.
Couldn't you just provide base containers for people to use, like an artifactor, and in the CI pipeline just provide a Jenkins library that is just a pipeline for a specific language? Then you can easily control how diverse your apps get. If you do multi-stage Docker, you can specify the the build stage, the unit test stage separately, but you only accept a very small amount of.
It's all doable.
Yeah.
It's just not being done. I mean, so I was an advisor to Docker for a little over a year, and Docker's lead investor was my lead investor at my startup. And I sat down with Solomon when it was .cloud and they were about to close the doors before Docker took off. And with all due respect to Solomon, he's a very smart guy. He's not a systems guy, and he didn't really get it. I mean, have you ever played with union file systems? Like once upon a time, I mean, they're not I mean, it's just, there's some odd choices he made, many odd choices. And so, I don't really want to knock him that much because, hey, people are using a shit ton of containers. And I actually think containers are going to be great for us. And I think that hypervisors were a sideshow that was based off of having too many 32-bit single-core apps or single-threaded apps in the land of 64-bit servers. And I think that we'll look back in 10 years and we'll go, hypervisors, virtualization, what was that? And containers will be the de facto way. That's what I really believe. And just we're here. So I'm gonna be the guy in the forest who's saying yell and follow me, and maybe some people will and some won't, but hopefully over time we'll get there.
And also just, we're recording, and it will be posted on our website until the end of days.
Great, I'm going to hear from HP.
I just would like, I'm just saying, like, the less I have to do editing to take out your colorful language afterwards, the better. So
It was only one, Lisa. It was only one.
Don't worry, Randy. Lisa doesn't worry being more.
Yeah.
I've had more clear in a really long time.
I dropped the F-bomb during
Lordy.
the EMEA Tech Summit internal Juniper sales training. Whoops.
Okay, well, this is our user group, and I have a code of conduct that I promise people I'll keep it clean. So I will edit that one out, but let's just.
I said unfudged.
Let's be on our best behavior.
All right,
just
so
saying, let's work for me later.
We've covered several. We've talked about beams make it easy, bare metals. Sounds like there's some agreement here that bare metal provisioning, if you can stomach it, if you can get the tooling right, if you get the processes right, if you're not trying to bring your VM mindset into how you're configuring and deploying containers, that's a better way to do it.
Hey, Paul, does Siri use containers at Apple? Yeah. Is it run on metal or VMs? Last I heard it was 80,000 plus. That's okay. I already got it from a guy by the name of Josh, but I forgot his last name.
Yeah, I mean, everybody I know runs containers.
Yeah. But if you're talking about eBay, talking about Apple and Google, then definitely they're running they have the experience, they have the engineering team, so they can manage the bare metal. But for the general, like fintech, this type of enterprise, they probably still prefer to have the virtual machines. But another point, I think, well, we start seeing people moving their critical applications into cloud. So if we believe this is the trend, and eventually most of the applications are running on the cloud, I think the tooling of bare metal or the virtual machine probably doesn't make much difference anymore.
I mean, at some point, Amazon's not going to want to pay the 20 or 30% performance penalty if all the hypervisors are doing is hosting containers, because that equates to 20 and 30% profit.
Yeah, but for the end user, they don't care if it's running inside.
I totally agree with that.
Okay, so can we hang on? We'll get there. Promise. So we talked a little. You touched briefly on firewalls, and then we moved on. But as one of the things that was mentioned when we were doing the prep was the notion that as security policies get abstracted away, how is that impacting firewalls, containerized firewalls? So, if you want to, I know Henrik had some ideas on this as well. So.
Yeah, I mean, Henrik was spot on when he was talking about kind of abstracting away sort of the firewall notions. Juniper's doing stuff around intent-based policies. I assume you guys are too. And that's just the notion of sort of getting away from ports and IP addresses and VLANs and network blocks and really focusing on having a policy that's attached to application or tiers of an application that follows around, goes with it as it scales up and down. Not rocket science, but in many ways it's great because it takes a lot of the security from the security teams where it does not belong, to the application developers where it does belong, right? I mean, if we basically held application developers responsible for their own security and then gave them all the tools and the training so that they could do it and held them accountable for any problems, just like Amazon does for operational stuff for Amazon.com, then we would get a much better outcome, right? The idea that we're going to go to this special cadre of SWAT, security guys who can solve all our security problems is just crazy. So the tooling has to get better.
Well, we see, a sort of a huge divide in that sort of space where enterprise customers are still sort of dividing security into traditional groups. So in many ways, the DevOps team will take responsibility for vulnerability scanning and keeping the registry clean, and there will be some gating mechanisms that will allow them to release or not. But once a container or a cluster is in production, that still, traditionally falls onto the security and network people to keep this thing running and keep it safe. And we see image drift, and we see all sorts of crazy stuff that sort of creeps in over time, right? So it comes out clean and pristine, and then over time it sort of morphs into something. Even though the word DevOps suggests it's one sort of big happy family, these, you're essentially asking the fox to guard the chickens, right? The developers, priority number one is to get features out as fast as possible, right? So you may skip certain protocols along the way, and once a container is in production, it takes on a life of its own, whether that life is 5 minutes or 5 days or half a year, and it's prone to the sort of the traditional attacks that the developer has no insight into, and so that's that's the whole premise.
So, yeah. Also, I think when people are talking about the shifting life, they're actually talking about image scanning, harden the system. But think about image scanning. This is not very much different from the antivirus or the API solutions, right? So you only scan your image at the time you scan that image. When you run that image in the runtime, there are other ways your containers can be compromised, and also there's zero-day attacks. So that's why I think the CI/CD process definitely important, but not enough.
I just think that's total bullshit. I'm sorry. I'm gonna rant. I'm so sick. So I got out of the security industry because it just became snake oil. I'm gonna find some new problem that I gotta sell you some new widget for, and it just escalation. And I feel like nobody wants to solve the security problems. And I'm gonna give you an example. The idea that these environments can diverge over time is accurate in the old world. There is no reason for them to diverge now. If you had a stripped down container that was 10 megabytes in size, it had only an application code in it, you could look for anomalies happening with that application at the code execution level, on the disk, in memory, in process space, and in processor execution. You can do all that relatively easily because you've scoped it down. Anybody remember Tripwire? Yeah. Remember running Tripwire on a big ass disk drive and it taking days and days and days? Well, if you want to run on a container, a 10 meg container, right, you could run it every 5 minutes. Bing, 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 bing. And that's a very old school technology, right? So I believe that the time has come for security vendors, including Juniper, to get off their arse and start building secure forensic analysis on a post-haste, because shoot it and replace it with another one automatically. Now, if I'm an attacker and I was trying to get into 1,000 containers and every time I breached one, it disappeared on me within 10 seconds, I would not get very far. And I just really think that this attitude of like, you've got to put kind of like static moats and gates that are semi-dynamic on top of it isn't the same as really addressing the root problem, which is how do I have security become much more dynamic, and how do I have it more attached to the actual way that the application is created and run in production?
Well, yeah, I agree. I think we just look at the issue at a different aspect. I believe you're saying, okay, so we can build the baseline at the, before the deployment, but actually enforcement actually happens in the runtime. So yes. If we are talking about the security at runtime, we're actually talking about how to enforce this baseline and do the anomaly detection.
Yeah.
One of the things we've done is we have created in a partnership with JFrog and Artifactory a sort of a feedback loop mechanism where when a container is compromised at runtime, it goes back and tags that container in Artifactory and notifies the developer. Isn't that a novelty, right?
Well done. That's more
but
the
that
mentality
is
I
sort
wanna
of,
see.
you know, that is in order to create some process and bridge that gap that you know that exists.
Questions? Yes, I mean, we have.
Yeah, I got a question. Thank you for the great information. Thank you for the great information. My question is, what is your opinion about technologies like trusted execution environments, Intel SGX, enclaves? How can those technologies help address some of these issues, especially if you're taking a holistic approach, like you're talking, you know, container-focused, container-centric, looking all the way to the application?
That's a great question. Before I went to Juniper, I was thinking about doing a startup that would take what is a very secure platform and basically take this into the data center, right? This has TPM on it. It's got the enclave. You know, all the applications run in containers, sandboxes. This is a very, very secure device. We know it's secure because the FBI has to ask for help in order to break it. So where nothing runs on the system unless you said it can run on the system. And once you're there, right, you can start to apply great things like machine learning to figure things out faster than the operations person would. You know, 10 of these containers suddenly had the same event occur. That should not happen. Isolate those things on the network and or shut them down so we can do forensic analysis on them. Don't even ask somebody. And it, you know, it's sad because the technology is really there, but we seem very resistant to deploying it. So, yeah.
So I have you know, sort of a real example of how hard that is in real life, right? So we implemented something called auto response rules, where you're setting up baselining and you're setting up sort of like anomaly rules. What should happen if we see X, Y, and Z? And if you're not careful, you know, we will quarantine the Nginx load balancer that sits in front of your entire application stack, and down it goes, right? And so I think, you know, the idea of shooting the containers down.
How many Nginx load balancers are there in front of your application stack?
Well, for one service, there's typically one, right?
Well, you've just proven the problem. You're treating your load balancer like a pet instead of cattle. There should be N or N plus 2, and if you cordoned off 1 or 2 of them, that shouldn't be a problem.
So I'm not disagreeing with the premise of shoot it down, and it will probably minimize the sort of the encouragement of the attacker. I'm just saying, what we see is people are very conservative when it comes to moving into security automation.
Yeah, sure. I mean, I think we would all agree that IT people are highly secure, highly conservative when it comes to automation. But the reality is that we're just not going to get there without it. And you know, you can do things like you could have a machine learning algorithm detect an anomaly within a few seconds, and then notify a security operator to validate it within a few minutes. I mean, it could be human. It can be ML assisted, right?
Yep,
So don't take my hyperbole and my extreme example as the only way of doing things, right? I mean, automation has its own dangers, but the danger, I mean, if you think that like machine learning and automation is not going to be applied to the attacker side, you're crazy.
Oh, yeah.
So if we don't do it first and really think about how to make these systems more secure, then we're gonna feel the brunt of it.
Attackers can take advantage of. So still runtime security, detect the process, detect the system call, still important. It's in the system level security is important, but application level security sometimes we are lacking, of tools to detect.
John,
Get a question in? Okay.
Or come.
I would disagree with the last statement. More of Kubernetes machine learning. I work for a security company, and we detect like 100,000 new attacks a week, which we feed back into our network. It's a question of just being able to detect this stuff. And it's continuous monitoring. It's not point in time. If you don't do continuous and continue updates, you waste time.
Humans can't even keep up with it anymore.
Yeah, you can't. I mean,
Totally impossible.
Because we get, how many gigabytes or terabytes now daily to analyze. And human beings can't do it.
Yeah, and most of it's junk.
And most of it is junk. But when you find the things you can push back, it's really, really valuable.
Super valuable, incredibly valuable.
Let's see. I think you had your hand up first. There you go. Then we want to talk about unikernels.
So you all mentioned, these kind of dynamic runtime scanning analysis tools. Our business model right now is we give software, we package software, customers run it on general purpose machines, VMs, bare metal, whatever. We'd like to switch to where we deliver container images that they can't mess around with. And a lot of customers run lots of different security scanning tools. Once we go to a container-based delivery model, they won't be able to put on all that junk and use those dynamic scanners. So, then it's kind of on us to choose, what we hope will work for a majority of our
No, you just let them run it from the host side because they can see into the containers from the host side.
Okay, and they have the tools will still work, you're saying, or the
Sure.
tools will be modified?
I mean, I don't know all the specific tools, but some percentage of them, some large percentage will work probably
Okay,
without
thank you.
modification. This gentleman over here.
Thank you. See, we talked about profiling the container-related applications and come up with a baseline and try to enforce it runtime.
Yeah.
But that leads into false positives. And how realistic it is to solve that problem using machine learning?
Well, you conflated two things. I haven't talked about using machine learning to deal with code path enforcement. Right? Those are two slightly different things, right? But could you be more clear about what you mean by
when you prepare a baseline, no?
Yeah.
Then when during runtime when you want to enforce it, you will run into false positives.
Like what? Give me an example of a false positive you would run into.
Means even though there is an attack, there is no attack, you may declare it as an attack. Because it's not easy, to come up with a good baseline.
I think you're conflating the security anomaly versus the actual code path runtimes.
Yes.
Which I think are two vastly separate things.
Right.
Randy's saying that we profile the application for actually hooks and calls that calls to the kernel in its operational practices, go through, look at the runtimes that it's pulling, to very heavily constrain what's available in the runtime. You're concerned over what happens in that runtime. They're a completely separate thing and not something that Randy's directly covered, and not what anyone's saying we do machine learning with.
Let me give you a simple example. A very common type of exploit in the past is a buffer overflow that gives you a shell access. So what you're doing is you're running over the memory that your application has access to in another part of memory space, and you're able to execute a shell and get access to it, right? Well, if you've baselined or you've profiled everything that your application does, and you know that it can never access certain parts of memory and or it can never access the shell executable and run it, then the minute it does those things that it's not supposed to do, you send up a flag. Right?
So what kind of tools we have to profile?
People have had code path enforcement tools for a long time now, actually. There are things that actually look at every code path that your code can run or execute, and they profile it all, and they basically whitelist all that. And then if your code ever tries to do anything else, it'll throw it. I'm trying to remember what was the one that Simon Crosby did real recently? Chromium?
Yeah, Bromium.
Chromium?
Yeah, Bromium.
Yeah. But that stuff's been around for a long time, and it just gets even easier. If you're going to use, for example, if you use a tool that runs your application as if it's in production to find out all the shared libraries that it talks to, you're going to exercise all the code paths.
Yeah, on paper it looks good, but doing that in reality and getting that to production, how realistic it is.
People have been doing that for a long time.
How come people are not come up with a tool so that others can adopt it? If
Well,
that is such a bulletproof solution.
Well, I didn't say it was bulletproof. It's bulletproof for that one aspect, which is basically watching the code path execution of a specific application, right? I mean, and let's back away from that specific solution because I'm just throwing up examples, right? Apple doesn't do that on an iPhone, right? They just use sandboxing, right? So you're inside of your sandbox, your container, and you can't access any of the other resources on the device. You're sort of locked down from accessing So they don't have to monitor every code path that your code runs, and it's too onerous for them to do that anyway, because all those apps are coming through the App Store, they're getting updated all the time, they can't go execute them all. So they take an even simpler approach to it. But whatever it is, the point is the anomaly-based detection, where you have sort of a whitelist model and you know what is appropriate behavior, is much more effective, because you're saying, this is the way the application works normally. If there's any deviation from this, then throw a flag, right? Whereas what we do now is we say, we have no idea how the application is going to behave. It could do anything. Let's just try to like put firewalls all the way around it and encrypt everything on disk and make sure the secrets are separated in a secret database. And like all of those pieces are sort of a kludge, where if we actually did know what the application is going to do, we could say, this is what the application does, this is all it does. If it does anything else, stop it.
But in microservices world, you have a well-defined thing,
Which makes it easier to actually do this.
Yeah. But I don't come across anybody who's automating this.
This is my point about the security industry being full of snake oil, is because it's not in their interest to basically try to solve some of these problems, because then it's going to be harder to sell you stuff. Sorry, Henrik.
I'm going to pass on that.
All right. There's one other topic that we had come up with in the prep, and that was about unikernels. Seems to come up every couple of years. We get to talk about unikernels again. But if there's, if you can get past the idea that you're avoiding, a breach tends to equal a ring zero bad day.
Don't steal my thunder, dude.
Well, we also got Mr. Unikernel in the audience, Ian. So, do you want to start?
By all means, start, and I'll review.
Maybe he doesn't need questions. He just needs topics, and then give him the mic.
You want to go first?
I guess so. There's nothing wrong with unikernels. They just don't belong in production. They're very useful for IoT devices.
So let's talk about ring zero. Why is that such a problem?
Repeat the question.
Because you can run privilege, you can run code at
Why is that a problem?
Because then you can access anywhere in memory.
Repeat the
Like other
question.
program?
Yeah.
So if I have one program per process, per VM, can I access another process inside that VM even though it's consigned to only one process per VM?
Let's do this maybe a different way. You buy that if you take a container and you actually strip it down, you reduce the attack surface dramatically, right?
Except for your gigabytes of containers that exist with shells and users and languages.
If you did it properly, right, as I laid out at the beginning, right?
Sure.
If you take the single application that's supposed to go in a container, much like a unikernel application, and you strip it down, then you've only got some very small number of lines of
You're
code.
speaking loudly. He's not. So.
So you buy that. I've reduced the attack surface, right? Okay, assuming it's done right. Now, if I introduce a kernel into that container, I've just now increased the attack surface because I've got the attack surface of the kernel itself, which in many cases, like the Linux kernel, is pretty significant compared to the size of a typical web application. Yes, right. There's stuff in there that if it's not stripped out, I could get access to. I might be able to basically shoot over precompiled kernel modules and load them up into the kernel itself. I have a lot more flexibility for what I can do. Inside a container that's been locked down, my options for accessing and loading kernel modules is basically zero.
I would argue that's not the case because containers by definition have to reside inside Linux. Even the stuff that's residing on Windows is actually inside of a tiny Linux VM.
Sure, but I'm running as an unprivileged user.
It still has the concept of multiple processes, which I argue is the main security problem out there. It's a concept that's 40 years, 50 years outdated for the way that developers actually push software out to VMs nowadays. I mean, what we're really talking about is the Unix model is broke. Like, we migrated a long time ago from Unix when we went to AWS. Like, every VM every process is now a VM. All the users, that's IAM. So that model's dead.
You're going to have to be more clear what you mean by
probably
that,
like
but I'll give it
one
to
of
you.
the worst security models out there, honestly.
Well, I mean, I understand that that's your opinion. I think I made a very good case for why that is actually a misunderstanding and a misuse of containers themselves. right? And you can look at the fact that Google is one of the most secure infrastructures we've ever seen that's running containers on metal, not unikernels and not VMs, and that's that gives us a pretty good understanding that containers, if run properly, can actually be quite secure.
But Randy, doesn't this come back to my original point, which is if you run a very homogeneous infrastructure where you can control the whole app stack, you can do it bare metal, very secure. If you, like most enterprises, run a very diverse
Yeah, but they're not
stack
taking
of
those
applications.
workloads and sticking them in
Right.
containers, Henrik. That's not what's happening. That's not where the growth is. The growth is on the new cloud-native apps. That's what's going in containers, and God bless you, unikernels. But they're not lit. Oracle RAC is not running any goddamn containers.
Okay.
Don't look at me.
All right. No, I'm looking at you as the timekeeper.
Is it over yet?
Can we go over?
I still want to mix it up with your friend because he's clearly knowledgeable. I might learn
I
something.
would,
He
I
might
would also
smack me
argue
down.
against Google because just like 4 months ago, the guy posted screenshots of Borg, which was God forbid not Docker running inside of Google, and of course that's all backed by VMs because they don't trust containers more than they can throw. So I mean, containers are completely broken security abstraction. I think that's the problem that you actually highlighted earlier was people were trying to use
Containers are not a security abstraction, but they can be configured securely. VMs are not a security abstraction, and unikernels are not a security abstraction. And in fact, I would argue that for the most part, most things aren't security abstractions except for dedicated tools like firewalls, right? But I'll show you what a firewall was. You probably aren't aware of this, but in 1992, when I deployed one of the first firewalls I ever did, there were no firewall products. So I had a router with ACLs, I had a bastion host that ran SOCs, and then I had another router with ACLs. That was a firewall that's a demilitarized zone. That is the classic definition. So a firewall is a security function more than it's a security product. And it's a way for you to enforce network security in a certain kind of way. Now, you're making an argument somehow that unikernels are more secure, and I'm trying to make a more abstract argument, which is it's less about like whether I pick a particular technology, whether it's a couple of routers at the bastion host or a checkpoint firewall. I'm trying, oh, sorry, Juniper, SRX. I'm trying to make the point that there are things that you use to sort of measure the security of the system and how you do the security architecture. Attack surface, attack vectors, all this kind of stuff. And when I look at something like a unikernel, like I'm not saying it's terrible. It might be good for running a specific firewall in a container environment to provide network firewall services. Certainly better than running that as a VM. But I would just argue that it's about how that thing is configured as much as it is about how a container is configured. Because I can tell you right now, I can build you a unikernel-based system that will be insecure as all hell and back.
Have you actually booted one before?
Just the stuff that comes with, an operating system like OS 10 for like the rump kernels and stuff for like,
Sure.
Just
because I mean, like the whole security model of unikernels in general is that they're single process by design, and so like as an attacker,
it's just no kernel.
Like my goal is not to exploit a piece of software. I could care less about what bug I'm trying to exploit. I'm trying to get on your server.
Yes.
So then I can like dump the database. I can run some cryptojacking code. Do whatever.
Yeah, but you violated like one of the first principles of defense in depth when you're running your process code at ring 0.
And what is that?
Defense in depth. You have to have multiple layers.
What
you want to run.
Violating?
You're violating the security principle called defense in depth.
If I do that, am I gonna hijack another process?
I'm being very clear with my words. I said you're violating a principle, and I think that's extremely clear. I don't think you need to misconstrue what I said because it's not helping your argument.
Okay.
You're violating
I
the
don't
principle.
understand the argument.
You don't understand the security principle of defense in depth. Do you know what defense in depth means?
Well, I know that I've been to several security shows in the past year, and like half the early stage people are all container security because container security is such a shit show of, why it almost makes the container market like worse. It's like Tesla got owned because they had Kubernetes open, all the different secrets.
I'm not making any arguments for
Tesla got
containers.
owned because they did not conform to best practices. Let's be clear about that. They had the control plane running on the public internet. If you fucking do that, you're asking for it.
That's also a violation of the defense in depth principle.
So,
Anyway, I think we should leave it. I
when-
get it.
when we say let's argue,
you're my unicron guy.
we
All right, I tell you, let's do this. Let's do this. We're over time, and I know just respecting people's schedules. We've got Lisa. If there's some protocols here, but what I propose we do is kind of let everybody take another beer, get some drink, get some pizza, cannolis. We have cannolis.
Cannolis.
Do we really have cannoli?
Yeah.
A couple of things. Okay, we're a little bit over, but we did allow a little bit of overage. If there's one question that people have been dying to ask that the shy people have not been able to ask, we could take one more question. Because I know what happens, because I've done this for 5 years. Y'all are just going to come storm the castle here, and these 3 people will be pinned to the wall, and it's probably the same question somebody else wants to ask too. So I'm willing to take one more question. And also, I just want to thank everybody for all the colorful language. Thank you, my friend. My video editing job is now going to keep me up for many more hours than it was. But you know what? That's a risk you run, particularly if you invite Randy to your house. Yes.
I have this reputation.
Love, you've earned this reputation. Anyone, one last question? Anyone? Anything? Okay, all right. And I'm trusting you that it's going to be a good one, because this is the last one. All right, darling, here you go.
I'm going to do my best. So one of the things that I found in my career, and my career is a network engineer, not necessarily servants or whatever, network engineer. So what I have found is that devices that I despise absolutely, I call them firewalls, the best value they provide is to prevent developers from doing stupid things. Just flat out stupid. Like accessing database directly from the web server or something like that instead of using an API, right? And then when they open firewall requests, it's like, I want to open a port, I want to access a database on port, I don't know, it's 1522 or something in Oracle, right? It gives the systems people an opportunity to say, why? That is probably the biggest value I've seen traditional security products provide, is give the systems people, the architects, the opportunity to tell the developer, you're an idiot.
Sure.
Right, and then how would you address, I can't frame this problem in any other way other than developer education. Like you mentioned that developers' primary job is to get features out of the door, and I 100% agree with that. That's what's bringing revenue, right? This is where we make money. But then, how do I make them slow down and say, you can't, you have to implement SSL in this connection. You can't just say, oh, build me a VPN tunnel and I'll just do unencrypted text, whatever, over it, right?
Why don't you figure out how to speed up?
In what sense?
You could use, for example, instead of a centralized network appliance, you could use a distributed host-based firewall that they don't have access to. You only have access to the containers. They could attempt to make a non-encrypted connection to a database. You could intercept that in real time, realize it wasn't allowed. Instead of just blocking it, you could actually send them a notification, email, or even an SMS to their phone and say, you're making an unencrypted connection to a database, which is not something that we allow in production. You need to basically fix your code. And by the way, it came from this specific application with this code release on this machine. And then you could take from doing that in production to doing it in the CI/CD and dev release pipeline as far back as you can. Maybe not on their laptop, but certainly in the staging environments. And that would allow you to catch that stuff even before it went to production.
And that's fair. And the argument they usually make is that you're slowing me down.
What they mean by that is that they want control. And so what you can do is you can create a situation where they can have control. What do they have control over? They have control over the code. If you tell them what they're doing wrong in the code, you show them where you're doing it wrong in the code, and you do it near real time, they have the opportunity to fix the code in real time and push a new code release. And in this world where we're trying to have rapid iterations, they shouldn't be able to complain about that. This is the same reason that public cloud kind of took off, is because the disk doesn't work, I call the API, spin up another disk. Network doesn't work, I call API, spin up another work, whatever it is. So if you empower them, but then spank them every time that they go to do something bad in real time and tell them what they did bad, they can change their behavior in real time. And this is part of what I mean, like the whole static thing where you set up those network appliances and and they have to file freaking ticket to like, you know, fix stuff. It's just of course they're going to try to round around it. The best security is security that is easy to adopt and use. The minute you make security difficult, people will route around it, and people are great at routing around things just like the internet.
Mm-hmm. Yeah, and that's fair. But we still find unencrypted as we call it. Not unencrypted, open access.
I'm telling you, there are ways to solve these problems that are different than the traditional ways. We have held on to these things like they're like we love them. I love it when the developer has to come to me and beg to open up a port between the two VLANs. Like,
I hate it. Yeah, I despise it.
Then you should be incentivized to fix it.
Priesthood.
And the second problem is that I can't scale it.
That's right.
There's not a firewall I can buy. I have let's say I have a limited supply of money. There's no firewall at my scale available to me to buy.
Yep. And that'll always be true as long as you're scaling up instead of scaling out.
All right, you did. You saved the best for last. You brought it. Thank you for the question. And I see that there's beer here. Now I'm understanding the language gets.
Sorry.
No worries. I'm sorry. There's just something I've been dying to do all night. Oh yeah. Okay, that's real. All right. I've been singing Nelly in my head all night long. It's
Which one?
death metal version, of course. It's getting hot in here. What do you mean? Which one? What Nelly song was in your head?
Country grammar.
Country grammar, because the fire reminded you of that. It is hot in here. You guys brought it. Thank you so much. We are going to network for another 13 minutes, so you can storm the castle. But I'm glad we got the last question in there. That was a good one. There is more pizza, I see. And thank you for whoever brought me the wine and the gluten-free pizza, because I can't do beer and pizza. So. Oh, thank you so much. The guy from Tennessee. Wow, awesome. So thank you all for coming, and we will see you on November 1st. That was Kriti, by the way, that I was talking to outside, so Oracle was in the house. She was just shy. So we'll see you November 1st in Redwood Shores, and we'll all be mingling for another 15 minutes. So thank you all. Big hand for Juniper for hosting. I have never seen a fireside chat quite like this one, so you guys really took it extremely seriously. So thank you for the fire. Thank you for whoever did that. Thank you to NeuVector. Thank you, Henrik and Greg. And thank you all for coming and being awesome members of this community. I'll see you guys on the 1st.
Yeah. All right.